All right, guys. So, in terms of the agenda today, I'm going to first give you an explanation of the cathode ray simulation that we worked on last time. And the information I provide to you should be enough for you to fill out your graphic organizer and understand what Thomson discovered. And then I'm going to walk you through how to do the gold foil simulation in class. So, hopefully, you have all the setup you need. I'll then kind of pause there and I'll go into the last three models in a separate video just so it's not getting convoluted and long. Also, I would like you to work on your lab safety quiz. So you're going to have the opportunity to find a lab safety quiz with all the answers on Canvas. And I want you to study those questions and answers because the exact same quiz is going to be provided to you. And I need you to have at least a 75% on that in order to do labs in the class. So that's why I'm giving you the quiz with the correct answers so you can go ahead and study that. So please make sure you do. And the lab safety quiz is going to be this Wednesday. I think that date is wrong, but so let's see, the 21st. Okay, so make sure that you are ready to take that quiz. It'll be on paper, okay? And then, of course, update your journal and your knowledge organizer. That's what the KO stands for, your knowledge organizer, with anything that would be helpful. All right, so first, the cathode ray experiment. That was this here. And I want you to notice that every time I make changes, okay, so this green thing here, it is going towards what? It's going towards the positive. And what if I switch them? It's still going towards the positive. Okay, that was iron. What about gold? Going towards the positive. Going towards the positive. It's always curving towards the positive. Okay, what types of things would go towards positive? And the answer is opposites attract. So that tells us that there's something negative inside the atom. The thing is, though, remember that this was what we thought before. It was a solid sphere and everything inside was everything inside. So what that told us is that if we thought this thing was neutral, that this was a solid sphere, so we thought, and then it was completely neutral, and we just discovered something negative inside since something is going towards the positive. We've discovered something negative, but we can also guess that there must be something positive in there to cancel out the negative. So if there's, for example, one negative charge in here, there must be also one positive charge in here to cancel it out. And that's how we came up with this model here, the Thomson model, also known as the plum pudding, but I'll give it another nickname in a moment. So we discovered the electron. He's the one who discovered the electron because we saw those negative particles continue to go towards the positive. And he hypothesized that like the rest of the thing must be positive because they have to cancel each other out. Plum pudding, you guys don't eat plum pudding anymore. So another model might be like a chocolate chip cookie dough, for example, or chocolate chip cookie. The majority of the cookie is cookie dough, and the chocolate chips are randomly placed throughout. It's not like we measure the distance of chocolate chips. They're just randomly in there. So the whole kind of cookie dough is positive, and then the chocolate chips are negative. Another example might be watermelon. So the seeds are randomly placed for the most part, but the majority of the watermelon is the red fruit. So that would be the positive red fruit and the negative seeds. Okay, so that's the plum pudding model or the Thomson model. Now I'm going to show you what Thomson's friend and colleague Rutherford kind of expanded on between this one and this one. And you guys are going to kind of reenact this one in class. So I'm going to walk you through the reenactment, and then in another video, I'll go over the understanding. So we think that the majority of the atom is positive and that there's some random negative things in there. So theoretically, if I shoot something positive at something positive, what should happen to that? In other words, if we have a positive and a positive thing near each other, do they like to go near each other? Do they push away from each other? What do you think happens? Well, if opposites attract, which is what we just kind of saw in our Thomson cathode ray activity, then theoretically, if things are the same charge, they should repel. So if we shoot positive, we're going to shoot alpha particles at a thing that's mostly positive, because that's what we think the cookie dough is, right? We think most of the cookie dough is positive. Then we should see those positive particles, those alpha particles, bouncing back. The majority of the time, we should see them bouncing back. That's the expectation. So you're actually going to practice this. You are going to have a whiteboard similar to this, and there's going to be something underneath, really that's like inside, if you will. So don't look underneath because we can't look inside the atom. It's the same kind of idea. And what you're going to do is you're going to have a flashlight, or it works best with a beam. We have some thermometers that have like an infrared ray. That would be best if I have enough with batteries. If not, some type of flashlight device can also work. And you're gonna essentially shoot it at the atom. So this is my atom, and I'm gonna shoot my alpha particle at my atom. And what you'll realistically do is shoot it under the board. Okay. So if I do that, I'm gonna set that there for a second. The best way to do this is, where did I put my piece of paper? Is to put something white or whatever on the other side, and you can see where the light goes through. Okay, so what you're going to do with your expo pen is, okay, well, here's the beam of light, and I can, oh, my pen doesn't work. I can see it going through there. So I'm going to draw a line on top to show that it's going through there. Okay, so again, let's hope this pen works. Try to keep your beam straight. It'll be a little bit easier. And I can see that it's going from here to here. Okay, I can see it shooting there. Again, it's better if it's a beam. I can actually see this whole range. The light is going through this whole range. And then you're going to kind of test it in all different angles. I'm going to go this way as well. I'm going to go this way as well, and see where the light is going through and where the light is not going through. Because again, you saw quite a bit of my alpha particle here going through, and it's not supposed to go through. It's supposed to be bouncing back a whole bunch of the times. So that's the activity you're going to do. You're going to see if you can see anything inside the particle, inside the atom, that maybe the particle wasn't going through, because we did say some, like, if the whole thing should be basically bouncing back every time we see that plus sign, we should see it bouncing back. Are we seeing that? Is it bouncing back? Is the light not going through for the majority of this? That's the first thing we need to understand. So see if you can hypothesize what's under there, and at the end of the lab, I'll let you go ahead and look under and see if your prediction is right. That's it.